Greetings everyone, welcome to Side A, Side B. In this video, a summer special, transforming a trig function, modeling a weather pattern from Hawaii. The overall plan, have a discussion, then model raw data with a sinusoidal function. So what's in our toolbox? How about what we know from previous studies? Ladies and gentlemen, imagine a chance. All expenses paid field trip to Hawaii. Study the weather for a year, collect data, then put your findings into a report. Aw, do we have to? Of course, if you don't want to, yes, we absolutely have to. First, let's see what can transform the periodic function y equals sine x. Like the period. Also considering the maximum and minimum. More formally, the period of a periodic function is the horizontal length of one complete cycle on its graph. It represents the distance on the x-axis it takes for the function's pattern to repeat. The pattern repeats at regular intervals. One complete repetition of this pattern is called a cycle. Another name for the max is a crest. It doesn't sound mathy at all, but maybe it's a better description. Maybe it's a better description sometimes for a discussion. What do you think? Another name for the min is trough. To identify the period, one way, consider the roots of a graph where the y-intercept equals 0, which is the x-axis. There's 3 here. Then notice where the graph rises, approaches 0. Then the graph decreases as it approaches the next 0. To identify the repetition, the graph should be rising again, approaching 0. We have 0 through 2 pi. Then, calculating distance, 2 pi minus 0 equals 2 pi. Voila! Since we just identified the period, we can list it. Next, what's the maximum or the crest, the highest point the graph reaches? Circled. The y value? Positive 1. Lastly, the minimum or trough, which is the lowest point the graph reaches. Circled. The y value? Negative 1. Next, find the axis or the midline. For that, we can use the equation of the axis, which is actually a y value. The midline is in between the max and min. The equation becomes maximum plus minimum all over 2. Which just becomes 1 minus 1, which is 0, over 2, which just equals 0. We have that y equals 0, the midline for y equals sine x. We still have to pick the team.
Anyone! Oh, pick me! Oh, I know, me!
Okay. We have one volunteer. Hang loose. For the amplitude, consider the max and min and midline is the distance between the midline and max and midline and min. Just to be clear, let's label what we want with arrows. Let's be daring. Boom. Copy the equation of the axis, then paste it. See that? Nice. With a minor adjustment, the equation to find the amplitude becomes max minus min all over 2. One minus -1 divided by 2, which is 1 plus 1 over 2, which equals 2 over 2, which just equals 1. Just a friendly reminder about distance. Amplitude is always an absolute value. We could have a negative in front of amplitude, but will always be interpreted as positive. The domain of sine x is the same as cosine, which is the open interval -infinity through positive infinity. This graph, the x-axis, is in terms of radians. The range is the max through the min on the y-axis, and we say it's the closed interval through -1 through +1. We use square brackets. So a closed interval in mathematics includes all real numbers between two specified endpoints, which were already mentioned. An open interval is denoted with curved brackets. Ladies and gentlemen, here's the setup. You've been chosen to lead a team of weather researchers to sunny Hawaii. The mission: study overall temperature trends across the planet by gathering average highs of cities. Your team's destination, the city of Honolulu. For an entire year, collect daily temperatures, then find the monthly averages. Next, use the best function to model your data. The report is due at the start of the next year. You have 1 month to prepare, which means if you celebrate the holidays, you'll be in Hawaii. Any objections? Bon voyage. Assuming everything's been done, one of the last things to consider, the characteristics of the periodic function and what are its values. As it were, modeling data with a sinusoidal function. Let's begin.